So let me kind of try to wrap this up for now by talking about a particular ordering, okay? And that's known as the lexicographic ordering. And the lexicographic ordering, fancy term, it just means dictionary order. So for example, AB is less than, and I'll try to put a fancy curse there, is less than ABC. AB is also less than, say, E, and so on, right? It's just which word do you find first in the dictionary, okay? But what we're going to say is we're going to define it, and we're only going to define it on pairs. So this is AB, A1, B1, and this is A2, B2. Right? And what we're going to say is, how do I know if A1, B1 is actually less than that? Okay, and what we'll do is we'll take two cases. I'm going to say that that's true, right? If A1 is strictly less than, oops, did I say strictly? Then I shouldn't put the little less than or equal to sign, should I? If it's strictly less than A2, right? So that's pretty common dictionary ordering. The B's come before the C's, the C's come before the D's, and so on, okay? It can also be true if A1 is equal to A2 and B1 is less than, in this case I can actually say less than or equal to B2, right? So example, the A's come before the B's, right? But let's say that both words start with an A. So now I just look at the second letter, right? And that's how I decide if one's less than or equal to other. If neither one of those is true, then it's false. Okay, that's what I mean by lexicographic order, and that's kind of encapsulated in this logical statement. A1, B1 is less than or equal to. That's the same thing as saying A1 is not equal to A2, and A1 is less than or equal to A2, which means that it's strictly less than, or A1 is equal to A2, and B1 is less than or equal to B2, right? So this and this are the same. Okay. Just one minor detail. Okay, I want you to really, really understand this. Here we have an ordering. This is an ordering on pairs. And here we have another ordering, right? This is an ordering on letters. Not pairs of letters, just letters. So the whole construction that we're doing is this. Suppose that you have an ordering over something, let's say the integers, okay? Then I'm going to show you how to build an ordering over pairs of those things. So pairs of integers, right? That's what this construction is. I've only showed it to you for pairs, but of course you can do triples, you can quadruples, you can go n-tuples, and you can even do arbitrary strings, right? You know, as soon as you run out of one, then it's smaller than the other one. Okay. All right. Quick example: 0, 3 is less than or equal to 1, 2. How come? Oh, that's just because 0 is less than 1. Right. So done. Okay. How about this one? 0, 3 is less than or equal to 0, 4. Well, we have 0 is equal to 0. And 3 is less than or equal to 4. Done. Okay, that's where those are coming from. Okay, couple of things that you actually should be able to prove. Okay, let's say that I start with a total ordering, right? Then in fact, when I generalize this ordering to handle tuples, I end up with a total ordering. Okay. If I have a well ordering, then the lexicographic order is also a well ordering, right? So both of these should be things that you prove, and I'll put them out as homework assignments.